Our topic is rainwater harvesting and how to build a rain barrel. We are 5th graders from Santa Rita Elementary. I am Cade Henry.
I'm Sutton Stelle.
I'm Carson Green. I am Hunter Show.
And I'm Sophia Templeton.
Water is a big issue all over the world. And if current water usage trends to continue by 2025, then 2/3 of the world's population, 5.3 billion people, will be vulnerable to water shortages. Texas is one of the states most hit by its climate change. We're in drought level 1, we have less than 24 months of water left. And not only does our part of Texas not get much rain, but the United States uses more water than other countries. This map shows how much water the United States uses. See here, the United States uses the most water per person per day.
Water use in San Angelo actually has improved. In 2010, the average use was 155 gallons per person per day. During the terrible drought of 2011, people started using more water, mainly on their lawns because it wasn't raining. In 2012, it looks like we're doing better, but we still need to conserve water. The average rainfall in 1 year is 19 inches. The average use in 1 year is 14 million gallons per day. The Hickory Aquifer will supply 6 million gallons per day. Rainwater harvesting is a system to collect rainwater off of a roof and put it in containers to use around the house and outdoors.
To deal with this issue, our group decided to focus on rainwater harvesting and how much someone could save even with using a single rain barrel. Our hypothesis: if rain barrels are used to collect for plant watering, the average home can save up to 55 gallons of water each time the rain barrel is filled.
Our plan to address our hypothesis was to identify how much water the residential light user, the residential heavy user, and the commercial user could save by collecting rainwater. We then determined the collection capacity, how much water they could collect off the roof, their storage capacity, the size of their tanks, and the water savings and water bill savings.
Our implementation plan is the following: rainwater harvesting workshop, November 10th, school poster contest, radio interview, October 29th, sample rain barrel, set up a demo of a rain barrel at Tractor Supply, trip to Dr. Ron Knight's rainwater harvesting system, grant proposal to set up more rain barrels and to get a pump to water the garden, Family Math and Science Night, January 24th.
This is our TRIYS group touring Dr. Ron Knight's water harvesting system. He has 4 3,000-gallon tanks and 2 1,500-gallon tanks. He uses these to water his garden and maintain his water feature, a pond.
This is his pump, going to his drip irrigation system. It is kept in this box to prevent freezing. This is his pond. It holds 10,000 gallons plus an underground storage to supply it.
This is his drip irrigation system for his raised garden beds. He has 5 others just like the one in the picture here.
It is also better to have a drip irrigation system because it soaks into the ground easier and less evaporates.
Since saving water was so important, we decided to make a poster contest for the young kids at our school so they can understand. We had 3rd and 4th graders make a poster as a class to explain rainwater harvesting. Miss Hammond's 3rd grade class won because they had the best explanation of rainwater harvesting. These have been hung up on the walls at school. The picture above shows the parts of the rain barrel. The downspout connects to the filter. The inlet is where the filter goes to keep out leaves and things from getting in the water. The overflow spout is if the rain barrel gets too full. It is also best to connect another rain barrel or a bigger bucket to conserve water. The spigot is to attach your hose and to water the garden. It is also best to raise your rain barrel to help the flow of water through gravity.
This is our TRIYS group at Family Math and Science Night. We set up an example of a rain barrel as well as facts about how to build them and water conservation facts. There were over 300 people there.
This is our school. We have a garden and we wanted to be able to water it and conserve water at the same time. The rain barrel we have now does not connect well, and the gutters we have are old and get clogged easily. This is the layout of our school. It shows where the rain barrels will be located and where they will collect off of. They will collect off the main building.
This is our grant for Lowe's. We found this after we were searching for grants at the library. We are asking for 2 50-gallon rain barrels that connect, a drip irrigation system for our garden, and solar-powered pumps. We will also put up signs to explain how it works. We are asking for $2,000.
To address our hypothesis, we found a heavy residential user, Dr. Ron Knight, a light user, which is my house, and we use it for mostly potted plants. And we found a commercial user, which is Baptist Memorial Retirement Home. They have a 16,000-gallon tank, and they use it for all of their landscaping.
This is how you can find the collection capacity for 1 year. You must, if 1 inch of rain equals 600 gallons on a 1,000 square foot roof, you need to find the square footage. Length times width, then you multiply by the amount of rain, and multiply by 0.62. This gives you the total amount of rainwater that can be collected in 1 year.
This is the table of data for our different users. Our light user could collect 16,657 gallons a year with 55 gallons of storage, but Hunter and his family only collected 956 gallons a year. Surprisingly, for that much water, they didn't save much money. Our heavy user, Dr. Ron Knight, also didn't save as much as he could, but he used a lot more. He uses 30,000 gallons a year. Our commercial user has a much bigger roof, but still isn't collecting all that he can off of it. Because this user mixes city water with rainwater, it was difficult to get an accurate measure on how much they saved, so we made an educated guess.
Based on our study, my house did not save all the water we could, but we still saved 956 gallons. And the users did not save as much money as we thought. Our recommendation is to charge more for water so people will use less.
Here are our resources and mentors. Our mentors were Dr. Christy Euchre from the Upper Colorado River Authority and Dr. Ron Knight, Master Gardener. We would also like to thank Ms. Wanda Green for helping us with the grant search. We are very thankful for their help.
Thank you for having us here. Are there any questions?